Hello, my dear students. Welcome back. Let me show you the demonstration of PS command with various options. Let me go to the online Linux terminal. The first options that can be used with PS command is -F that will display a full listing showing PPID of each process. Then observe the output. It will list all the attributes of the currently running process along with PPID, parent process ID. Next option that can be used with PS command is -E, which will display all processes including user and system processes. See, if you observe the output, it is listing both user processes and system processes. So user processes are like Tiny, SH, Node, SSHD, and user processes are Bash and PS. The next option is -A, which lists processes of all users, including system processes. PS -A. It will list all processes of all users, including system processes. Sorry, excluding system processes. So currently there is only one user. So it will display the list of currently running process on that particular user. The next option is PS with -L option. So this will display long listing showing memory related information. You can see here, if you observe the output. So these are the memory related informations. This part. And let me demonstrate the mechanism of process creation. So for this demonstration, let me create a C file. I'm using the view editor to create the C program file. Type at the prompt vi followed by the file name. Say the file name is test.c, and then type the program. The header file required are stdio.h, and then unistd.h, then stdlib.h. Then write the main function. So as I said, there are three distinct phases of process creation. First phase is fork, second phase is exec, and the third phase is wait. So let us declare a variable to store the return value of the fork system call. The return type of fork system call is PID underscore T. So the variable name is say PID. So the variable PID is of type PID underscore T, which is equivalent to your integer data type. Then execute the fork system call. And store the return value in the variable PID. As I said, the fork system call on success, it returns two values, 0 to the child process and the process ID of the child to the parent process. Okay. On error, the fork system call returns a negative value. So to proceed, you have to check the return value of the fork system call, which is stored in the variable PID. So use if statement to check the return value of the fork system call. If PID is less than 0, there is negative value, then there is some problem with creating the child process. So print an error message, printf, say the message is fork failed due to some reason, and exit from the program. Call the exit function. Else, if fork system call is executed successfully, and check the return value which is stored in variable PID. If PID is equal to 0, it means that the child process is running. I'm writing the comment here to know that the child process is running. So this child process execute the one of the family of exec system call, say exec LP, to execute a new program. So in this example, we are executing the ls program. The first argument to this exec LP is the program name, that is ls. So actually I'm giving the path name of the ls program. The ls program is stored under /bin directory. Enclose the argument in double quotes. Then the second argument, program name, simply ls. Okay. And what follows is a list of arguments, and the list of arguments must end with a null pointer. Now this execlp will execute the ls program, which will list the contents of the current directory. So if the child process is running, it will execute a new program, that is, in our example, it is ls program. Otherwise, the parent process is running. How do you know that the parent process is running? So the return value is the PID of the child process is returned to the parent process. Now I will just call the wait system call. So we are calling the wait system call to inform the parent process to wait until the child process is completed. So once the child process is completed execution, parent process will continue its execution. Then how do you know that the child process has terminated? Print a message. Child finish. Then end the main program and save the program. Now compile the C program using the C compiler, cc test.c. So there is one warning, you can ignore it. Then how to run the program? Yeah. Executable after compiling the C program, executable file a.out has been created. Just run the a.out file /. See, observe the output. So ls command or ls program started running. So it will list the contents of the current working directory. In the sense, it will list the files in the current working directory. And then once the execution of ls program is finished, okay, it will print a message saying child finished. That's it.